Addition and subtraction of vectors in 2D. So here we're going to look at how we can add and subtract vectors. Let's start by adding vectors. Let's draw up our XY axis just to help visualize some things. And let's draw in a vector A. And we'll draw in another vector B. And let's call this point A, B, and C. So these are all the points that the vectors are going to. And when we talk about addition of vectors, we want to look at, well, the resultant of going from A to B, then B to C, is just going from A to C. And that there is actually the addition of the vectors. So that vector there we can define as A plus B. And when we're adding vectors, all we want to do is make sure when we draw our first vector and then take our next vector and connect its tail to the head of the previous one. Then to get the resultant vector here, we're just starting from our initial tail and moving to our final arrowhead. And that gives us the addition of the two vectors. And even if the vectors were separated, remember the vector only depends on its magnitude and direction. We can always move a vector around. So a vector A and B, we can always move them around so that the tail of one and the tip of the other are joining. So we could do something like that. And then our addition of these two vectors is this vector here, A plus B. So it doesn't matter if the vectors are not connected, we can move them around so that they are connected and we get our addition of vectors. And yeah, we can think about this as the triangle law of addition. So where we're basically making a triangle with our two vectors. It actually wouldn't even matter if there was more than two vectors, because we could constantly join the tails and the arrowheads together, and it wouldn't matter what we end up with, because the resultant vector would just be going from that starting tail to the final arrowhead, and that would be the addition of all four of those vectors in this case. So let's also look at another example when we have two vectors where their tails are actually together. So we have vector A and vector B. And the addition of these two vectors can be thought of as if we moved B to up here, and imagine A being moved over here, that would actually form a parallelogram. And moving B up here shows that the resultant vector is going from there to there. And this is actually A plus B. And we call this the parallelogram law of addition. So if you have two vectors where they're both coming from the same tail, the vector that would form the parallelogram would be the addition of those two vectors. What if we had the vector A and a vector minus B? Well, again, we're just looking at going from the tail to the final head, and we get A plus negative B. And just like normal integer rules, this just becomes A minus B. Let's have a look at another case where two vectors are coming from the same point. Call this one vector A and this one vector B. Now, the resultant vector would be, we can find it similar way to before using the addition, but what about an expression for the subtraction of vectors? So what we can do is we can imagine either A or B acting in a negative direction. So we can imagine B going like this, and this would be negative B because it's acting in the exact opposite direction, which would mean this would be the resultant vector, which is the addition of these two, which is A minus B. But that's actually the same vector as this one here, A minus B. So when we have two vectors that are coming from the same starting point, the expression for A minus B can be thought of as going from the head of B towards the head of A. And that's how we can get an expression for A minus B when they're starting from the same starting point.